Welcome back, everybody. Today we're going to talk about solving multi-step inequalities. These are the ones that are more just adding or subtracting, multiplying, dividing. There's going to be at least 2 steps to these. So let's talk about those steps. These steps are going to be the same as what they were last chapter for multi-step equations. We want to start with eliminate grouping symbols, which are usually going to be parentheses, and we will use distributing to do so. The next thing we want to do is combine our like terms by adding or subtracting. Remember, when we combine like terms, whether it's on the same side or across the inequality, we only ever add or subtract to do so. Our last step is to use our backwards order of operations to isolate and solve for the variable. I'm going to have a couple of things here that we want to make sure we don't forget. First, don't forget when you multiply or divide by a negative value, our inequality sign changes direction. And then we need to check for special solutions if our variables eliminate out. And we'll talk about what those look like a little bit later in these notes. So let's try a couple. Solve each inequality and graph the solution. So remember, I'm again looking at this. And for number 1, I don't see any grouping symbols, so I don't need to worry about distributing. Don't have any like variables, so I don't need to combine those. So I'm starting with PEMDAS backwards or SEDMA, and I am adding 7 right now. The opposite of adding 7 is subtracting 7. Now remember, subtraction is not part of changing our inequality sign. So these add to 0, sign same's the same direction, and 9 minus 7 is 2. Then I take a look and say I have y divided by negative 6. The opposite of dividing by negative 6 is multiplying by negative 6 on both sides. The negative 6's reduce to 1. So we have 1y. We multiplied by a negative, so our inequality has to change directions. And then 2 times negative 6 is negative 12. Our solution then is y is greater than negative 12. Graph our solution. We have an open circle at negative 12. Greater than goes to the right towards positive infinity. Number 2, I don't have any grouping symbols, so I don't need to distribute. I don't have any like variables on any side, so I don't have to combine those like terms. So I'm working on SEDMA again. The opposite of subtracting 4 is adding 4. We have 2v. Negative 4 plus 4 is 0. 8 plus 4 is 12. The opposite of multiplying v by 2 is dividing v by 2. 2 divided by 2 is 1, so we have 1v. We did not divide by a negative, so we do not need to worry about changing the direction of our inequality sign. And 12 divided by 2 is 6. That makes our solution v is greater than or equal to 6. To graph our solution, we have a closed circle at 6 because of the equal to sign. Greater than, again, is to the right towards positive infinity. Second and fifth hour, please do 4 and 6. Fourth and sixth hour, please do 3 and 5. More examples of solving. For number 7, I don't have any parentheses, so I don't have to worry about distributing to get rid of grouping symbols. But I do have a 2x and a 6x on opposite sides. Remember, this inequality is the same as our wall. So when we're moving from one side to the other, we're doing opposite operations. And we always combine like terms using adding or subtracting. Because this is a positive 2x, the opposite is to subtract 2x. 6x minus 2x is 4x minus 5. Subtraction does not change the direction of our inequality. These x's add to 0, and we have positive 11. Next step would be to add 5 to the other side. So we have 4x. Those add to 0. 11 plus 5 is 16. Our last step is to divide by 4. We're not dividing by a negative, so we don't have to change the direction of our inequality. And 16 divided by 4 is 4. So our solution is x is less than 4. To graph our inequality, we have an open circle at 4 because this is not equal to, less than, left, less, left, going towards negative infinity. Okay, number 8. It's a super important number. This is where we're starting to talk about some special solutions. We start with, I have grouping symbols. So we need to distribute to get rid of those parentheses. 4 times 2b is 8b, and 4 times negative 3 is negative 12. Next step is to combine like terms. We're hopping over a wall there, over the inequality. So we're doing opposite operations. And we always combine like terms by adding or subtracting. This is a positive 8b, so the opposite is to subtract. 8 minus 8 is 0. Remember, we don't write the b. It's zeroed out. It's gone. Don't forget to bring that negative down with the 3. The inequality does not change signs or direction, when we're subtracting. 8b minus 8b is 0. I don't write a b. And we have negative 12. So because our inequality, the variables canceled out, we have negative 3 is greater than negative 12. I actually want to go back and I want to change this subtraction to a positive sign or an addition sign. which makes that a positive 12 and this a positive 12. And the reason why I want to do that is because of our special solution. So this question is true or false? Is negative 3 greater than positive 12? And the answer to that is no. This is a false statement. If negative 3 is not greater than positive 12, then this has no solution. How do we graph no solution? Well, we're going to put some numbers on a number line, and we don't shade anything at all. So I'm going to mark that over here in red. So if we have a false statement, false means there's no solution. The graph of no solution is a number line. You can put any 3 numbers you want there, and you don't shade anything. Number 9 is going to be our other very important one with special solutions. I'm again going to start with getting rid of our grouping symbols. 2 times 5w is 10w. 2 times negative 1 is negative 2. Combining our like variables across the equal sign. Remember, we only add or subtract. So I'm going to subtract 10w. 10 minus 10 is 0w. 0w, we don't write that down. We're left with the negative 2 because we're not going to forget to bring down that negative sign. We subtracted, it does not change our inequality. We have 7. And again, 10 minus 10 is 0w. We do not write w down at all. Again, our question here is negative 2 less than or equal to 7? Is that true or false? And in this case, it's true. Negative 2 is less than 7. That makes the answer to number 9, infinitely many solutions. And when we graph infinitely many solutions, again, it doesn't matter what numbers we have on our number line. And then we shade the whole thing because we can have anything we want. Infinitely many solutions. We can have anything we want because it's true. Second and fifth hour, please try 10 and 12. Fourth and sixth hour, please try 11 and 13. This is where we are going to stop for today. Have a great rest of your evening.